So, good afternoon, everyone. Welcome to afternoon session of day 4. So, today we have one speaker, Dr. Kumar, who is working as an assistant professor in the Department of Computer Science and Information System, Pilani, Hyderabad. And he received his PhD in Computer Science Engineering from NIT Rourkela under the senior most professor of Computer Science Department, Professor Dr. Kumar Rath. His current research interests are in the area of data mining, mining software repositories, artificial intelligence, machine learning, software analytics, social media analytics, to name a few. His thesis, PhD thesis is titled is based upon the prediction of software quality parameters using artificial intelligence techniques and source code metrics. He was a faculty member at Thapar University from 2017, in the year of 2017. After that, he is working here. He has published several papers in international conferences, journals, and he has a broad range of interest in research areas, various research areas. And recently, he received one project grant from Test AING Solution Private Limited, and he has given so many invited talks. And one of the talk he has delivered at Indian Institute of Science, Bengaluru, and many research scholars are also working, MTech and BTech students are also working. He received so many awards like Young Scientist Award and Best Researcher Award and so many Best Paper Award, and published numerous journals paper, especially SCI journals, and very top tier conferences, and delivered several talks, and he is interested in many various engineering techniques based upon the artificial intelligence and machine learning. So with this brief introduction, I request Dr. Kumar, who is one of my favorite junior, to develop to take this session and highlights about his developed techniques.
Yeah, thank you, sir. So good afternoon, everyone. So can you please check my voice is audible or not?
Yes, it is audible.
Okay, and my PPT is visible or not?
Yes.
Okay, thank you. Okay, so in this session, basically, I will focus on the assemble method in artificial intelligence, means how to use the assemble technique. So basically, as we know, not a single technique always gives the better results. So when you are working for the any data set, so in this case, some case it may be happen like that, decision tree will give you better result. Some case it may happen like that, logistic regression will give better result. Some case the artificial neural network will give you the better result. But it is not like that, you can claim like that. So a single technique will always give the better result in all the data set. It is not like that. Then in case of assemble technique, what we are going to do, why not we can assemble all the techniques, either decision tree, logistic regression and ANN, and we will make one single technique that will work like a decision tree, also work like a logistic regression, and also work like a artificial neural network. So in this case, what will happen? Definitely it will give you the better result as compared to the decision tree, logistic regression and artificial neural network in all the scenario. So it is not like that in one scenario the decision tree is giving the best result, but it is not for the assemble technique. It will give you the on an average result for all the cases. Okay. So basically I have prepared the slide for one data set that is called the Android malware data. Okay, so our objective is mainly to develop one technique, and that is used to predict whether the Android application containing some malware or not, based on some assemble technique or based on some artificial intelligence technique. So these are the seminar outlines. So we will also give some little bit introduction about the feature validation method, means how to select relevant feature or how to select the right set of relevant features, because this is proposed by me, so that is totally different from the rest of the feature selection method. So I'm not going to the basic about the Android malware prediction. Directly I'm going for the challenges. So when you are working for the any cases, any types of data set, in this case basically you are getting the three major challenges. Okay, when you are working for any data set. So first one, your aggregation matrix. Second one, your high dimensional data. and third one is your imbalanced data. So nowadays, whatever the data you are getting related to the classification technique, most of the data are suffering from class imbalance problem. And most of the time we are going to ignore this step. Directly we are using the machine learning technique. We are not going for the aggregation matrix. We are not going for the high dimensional data. We are not handling the class imbalance problem. Directly we are going for the model development without using this step. So now we will see one by one what is the importance of this aggregation technique, what is the importance of this high dimensional data, and what is the importance of this imbalance technique. And after that we will start the assemble of different classification prediction technique, and we will also see about the bagging and boosting technique. So first one, if someone will ask you, simple example, if someone will ask you to compare the two different departments, one is called the computer science department and second one is called the electronics department, okay, EC department. Now assume that in computer science department the total number of students is 20, in electronics department total number of students is 10, okay. And if you are going to compare this department based on the CGPA, how to compare? Anyone, how to compare these two departments based on the CGPA? You can put your answer in the chat box. So I think this page is visible to all. This page, what we are going to write. So anyone? If we are going to compare computer science and EC department, now my question is simple like that. We are going to compare two different departments, computer science and EC department. Based on the CGPA of the student, in computer science, the total number of students are 20, in EC 10, okay. Then in this case, we are going to compare. Okay, so some are saying like that we can consider the average value, okay, mean value, okay. Now assume that we are giving one simple example, 10, 20 and 30, and second one 10, 50 and 0. What is the mean value of these two data? Now assume this is one data and this one is another data. What is the mean value we will get? In the first data, what is the average value? In second data, what is the average value? What is the average value we will get in the first data or in the second data? Okay, average value. I am talking about the average summation of all number. Okay, so can you please check? Now it is okay. Image is okay.
Yes, sir.
Is there any problem?
30 and 20.
Hello. Okay, so it is coming opposite. How many are getting opposite? Can you please check? Now I am checking. Now it is okay. Can you please check? Image is fine. Okay. So now you can see in both the case, just we are getting 10 plus 20 plus 30 divided by 3 and 10 plus 50 plus 0 divided by 3. So in both the case, we are getting the average value equal to 20. In both the cases, we are getting the average value equal to 20. But can we say, because based on the average value, what we are going to say? We are saying like that both the data are equal. But can we say both the data are equal? Can we say? Because based on the value, we are getting 20 here, we are getting 20 here. Okay, so based on the average value, we are saying like both the data are equal, but actually both the data are not equal. And most of the time we are doing mistake here. Most of the time what we are going to observe, we are using only average value to aggregate the data. And where we are using the aggregation technique, so as for example, if you are working for IoT data, if you are working for single IoT data, okay. Now you are working for the temperature sensor data and you are collecting the temperature of any room. At every 5 minutes, you are collecting one temperature data. Every 5 minutes, you are collecting one temperature data. Okay, so every 5 minutes, you are collecting one temperature data. So now within hours, how many data you are going to collect? 12 data. Now assume that if you are going to analyze
the image is reverse, sir.
Sorry?
Image is reverse.
Okay. Now it is okay. Now it is okay. Can you please check? Sometime it is coming for only 1 or 2 seconds. Image is okay. Some case it is coming image is okay. Can you please check from your side? Because you can.
Image is fine, sir.
Yeah, image is fine. Okay. So now assume that if you are working for 10-year data, so then in this case you will get a huge number of data sample, because within an hour you are getting 12 data. If you are talking about within a day, you are getting 24 into 12. Within a year you are getting this much, and if you are going for the 10-year, you will get the huge number of data. Again, it becomes very challenging to handle this data. Then in this case, what we can do, why not we can aggregate 1 hour data to a single data? Means within a 1 hour, whatever the data we are collected, we will make only one sample for each hour. Okay, initially we are collecting at every 5 minutes, we are collecting one data. But what we are going to do, for 1 hour data, we are going to aggregate the data and we will make one single data. Same like that, either you will make 1 day data, full 1 day data, and you will aggregate and you will make one single data. But the problem is like that, we cannot use the single aggregation technique, because if you are using the single aggregation technique, in this case, you are using the so many information related to the data. So in this case, basically, we will use more than one aggregation technique. And what do you mean by aggregation technique? Means it will take multiple input and it will return single output. It will return exactly one output. That is called the aggregation technique. Okay, so you can also consider the maximum value. You can also consider the minimum value. You can also consider the mean value, quartile 1, quartile 3, variance, standard deviation. So at least you will consider the 10 to different aggregation techniques so that you cannot lose your information. Okay, so this is one way of using the aggregation technique to reduce the number of samples. Okay, now the second thing is like that also, when you are working for, now assume that when you are working for the 10,000 different samples. 10,000 different samples. Now assume that in your system you can only process the 2,000 different samples. Then in this case also you can use this aggregation technique to reduce the number of samples. Because if you are using the other sampling technique like the random sampling, randomly you are selecting the data, then in this case you are losing the information. But when you are using the aggregation technique, you are losing very few information. You are not losing the whole information. Okay, so when we are going for the any comparison, that in this case we will not only consider single aggregation technique, we will consider more than one aggregation technique. Okay, so Miss, what you are talking about, the discrete data or discrete data? If you are talking about discrete data, because the question is, okay, so in case of discrete data, you can consider the maximum value, you can consider the minimum value, number of distinct value, this is also possible. You can also consider the median value, you can also consider the frequency of the unique value, something like that. So these all are called the aggregation technique. These all are called aggregation technique. So in case of discrete data, you will define the aggregation technique such a way that it will handle the discrete data. Okay, so as for example, mean you can consider. You can also consider the frequency of a specific term. So as for example, now assume that we already know there are 5 unique value exist in this discrete data. Then we will consider the frequency of each unique word, each unique number or something like that. So this is a first one. Now second is also most important, that is called the high dimensional data. Whatever the data we are getting, so when we are making the data set, in this case, we are not going to decide what purpose we will make this data set. So as for example, now assume that we are taking one simple example of a student management system. So when we are making the database for a student management system, that in this case, we are going to store all the information related to the student. But in the future, if you are getting one objective like that, you have to find how many students whose CGPA is greater than 7.5. Then in this case, can we consider all data? Can we consider all feature value? We will not consider all feature value. We will consider only one feature value, that is called the CGPA of the student. And how we know? How we know this objective is totally related to one feature value? Because we have the idea about the domain. We have the domain knowledge. That's why we can directly find this information or this objective is totally related to feature value CGPA. But now assume that when you have no any idea about the domain knowledge, if you are working for the biological data, if you are working for the social network data, if you are working for the Twitter data analysis, then in this case you have no any idea about the all information or all features, because in the case of biological data the number of features are 1 lakh, 2 lakh, something like that. In case of Twitter data, if you are going to consider the word as each feature, you will get the something like 10,000 or 20,000 different words. Then in this case, it is not possible to manually, it is not possible to find which features are important and which features are not important. So now after 1 or 2 slides, we will see how to use this feature selection technique. Now next one is also important, that is called the class imbalance problem. Okay, so class imbalance problem is, as for example, now assume that if you have the 1,000 students, out of 1,000 students, now assume that 950 students already placed and 50 students not placed. Okay, out of 1,000 students, 950 already placed and 50 students not placed. Okay, now assume that if you are going to make one model, okay, and now assume that this model is always predicting the student teach place, always predicting the student teach place. Can you find what is the accuracy of this model? If you are going to test this model in your data set or your student, then in this case, can you find what is the accuracy of the model? Anyone, what is the accuracy of the model? If the model is saying always place, 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 something like that, can you find what is the accuracy of the model? Anyone? Anyone, what is the accuracy of this model? 95%. Okay, good. So we are getting the very high accuracy, 95%. But can we say this is a feasible model? Can we say this is a feasible model? Because in all the cases, what it is going to predict? It is predicting place, 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 and we are getting the high accuracy. And based on, because 95% accuracy is very good accuracy, and based on this accuracy, we are going to decide like that we can use this model. But actually, this model is not doing anything. This model is only predicting place, place, place. Okay, so there is something problem with this model, and why this problem is arising? Because of this imbalanced data. Because our data is not balanced. The number of sample belongs to each class is not same. So balance means the number of sample belongs to each class must be same or nearly equal to same. So it is like that 60-40% is true, 60 or 55, 45% is a balanced data. But if you are going to consider 95%, 5%, this is called the highly imbalanced data. So in this case, directly we will not go for the machine learning technique. First, we have to find some model. First, we have to define some technique that is used to check or that is used to balance this data from imbalanced data to balanced data. Okay. So now I'm going to give you some little bit idea about this, how to make this imbalanced data to balanced data. So you have 950 students, 50 students. What is the first approach? Randomly you have to select 50 students from here, 50 students from here. Now your data become balanced. So now we are not going to consider all the data. Randomly we are selecting the 50 students from out of 950 here and the 50 students from here. Now your data become balanced. This is also called the random sampling. Random sampling. So this is also called the random sampling. Cross validation, here also it will not work. Cross validation will not work. So when you are going to balance the data, then it will work. Cross validation will work. If you are going to balance the data, after that we can use cross validation. Is basically used for validation of model. It is not used for the balancing of data. That is a totally different concept. Okay. Now next one is, this is a very easy task, but now assume that someone will give you the task like that, 950 and this one is 50. How to make this 50 data to 950 data? Out of 950 data, we can select the 50 data, but how to make this 50 data to 950 data? Anyone? How to make this 50 data to 950 data? Anyone? No, if you are going to repeat the data again, this is not a good task. Resampling means how you are going to resample. Duplicate data is not a good way to. PCA is a different thing. PCA is basically used for the feature extraction. PCA is basically used for the feature extraction. Okay, so now assume that we are going to use, basically we have used this technique in our research work. So now we can use the 95% confidence interval. I think you have already idea about the 95% confidence interval. So 95% confidence interval means 95% time it will give you the two value A and B. 95% time the feature value will vary from A to B. 95% time the feature value varies from A to B if you are going to consider 95% confidence interval. Okay, and the direct you can use this formula mean of X plus minus. If you are going to find 95% confidence interval, 1.96 into a standard deviation divided by square root of A. So directly you can use this formula. If you are going for the normal distribution curve, then definitely this value will come nearly equal to same 1.96. Okay. So X mean plus minus 1.96 into a standard deviation divided by square root of A. Okay. And what do you mean by that? 95% case the value will vary from A to B. Okay. Now you can see how we are going to generate. Okay. Now assume that the same like that. Now assume that this is your computer science department in your college. Okay. Now assume that in the total number of students in your department is 10. Okay. Total number of students in your department is 10. Okay. Now for a specific event, there is one event is going to happen in college B, and now assume that your student is going to participate in this event, but the condition is like that minimum 20 computer science students can participate in any event. But if you have only 10 computer science students, in this case, what is the procedure to make this 10 to 20? Anyone? What is the procedure to make this 10 to 20? Anyone? How to make this 10 to 20? Now assume that this is one event B. Okay. Now assume that your computer science student is interested to participate in this event, but in this case, minimum 20 students are required. Then in this case, what is the approach? Okay, so we will go for the other department. Okay, but randomly or blindly we will not select the other department student. First we have to check whether this student is more similar to computer science student or not. Whether this student in the EC department, we will go and search some student, because blindly we will not, or randomly we will not take the student. We will take those students those are more similar to computer science student. And how to find? We have to check the subject knowledge. We have to check whether this other computer science student have registered the courses like data structure, machine learning, data mining, or something like that, or not. If they have registered, then in this case we can say like that these students are little bit similar to computer science student, and we will give more importance to those students those are more similar to computer science. Okay. Now here we can follow the same approach. First we will use the feature 1, and we will find what is the feature 1 value in case of not place. Okay. Now assume that we are taking feature 1 as a CGPA. And we will find what is the CGPA of the student in case of not place. If the student is not going to place, what is the value? What is the 95% confidence interval of CGPA? And we are getting the value now, assume that 7.5 to 9, something like that. Means if the student is not going to place, then in this case, 95% case, the CGPA of the student will vary from 7.5 to 9. This is the statistic we have calculated using this formula. Okay. Now assume that after that, if we are generating one random data 8, can we say this student is more similar to non-place student? Can we say? Because 95% case, the CGPA of the student is between 7.5 to 9. So now what we can do, we will generate 900 random data between 7.5 to 9, because whatever the 900 data, if you are going to generate 7.5 to 9, that become your more similar to non-place student. That become more similar to non-place student. So you can also use this method. This method is called the upsampling technique. This method is called upsampling technique. Clear? So any doubt in this technique, upsampling technique? Any doubt? Upsampling, and the first one your random sampling. Because normally we are getting these challenges when you are working for any machine learning project. Definitely you will get challenged. First you have to check that whether your data is balanced or not, and if your data is not balanced, then first you will work for the balancing technique. So these are the different types of balancing technique. We will also go for the smooth and some other technique. Okay, now some had also doubt, so now we are going to explain again. What we are going to take 95% confidence interval. 95% confidence interval means it will return true value A and B, and you will think like that. 95% case, the value of any feature, if you are going to consider for feature 1, 95% case, the value of this feature will vary between A to D. A to D. Okay. Now assume that we are getting one feature. Now assume that this is your CGPA of none places to it, and we are getting 7 to 9, 7.5 to 9. Means 95% case, if the student is not going to place, in this case, the CGPA of the student will vary from 7.5 to 9. Now, in this case, what we can do, between 7.5 to 9, we will generate 900 different random number. You will generate 900 different random number. Definitely this number, whatever the number you are going to generate, 7.6, 7.7, 8, 8.5, these all are more similar to non-place student, because we have already idea that non-place student, the CGPA varies from 7.5 to 9, something like that. So we can use this method to generate our data. We cannot use the same data, better we will use this data. No, sampling technique, overfitting and underfitting, that we will covered in during the validation method. During the validation method. So if you are using the holdout method, then in this case, definitely most of the time your model is suffering from overfitting and underfitting. That's why we are using the k-fold cross validation. But in this case, basically we are using this method to make our data sample or our data balance. Okay. Now we are going for this one we are not going to discuss. Okay, so this one basically proposed by us means how to use the software feature validation. So just we are going to explain how we are going to use the software feature selection technique. So normally what we are going to do, normally most of the time what we are going to do, simply we are using the VCAP feature selection technique or in the MATLAB feature selection technique or some other tool feature selection technique. But before going for the feature selection technique, first we have to go for the univariate feature selection technique. First we will go for the univariate feature selection technique. Okay. So now you can see what we are going to do. Now assume that we are taking the same like that, place a student and not place a student. Okay. There are two categories. Okay. Okay, so I think one question is coming like that. Why we will go for upsampling? Anyone? Why we will go for upsampling? Anyone? Because one question is coming, why we are going for upsampling? Because we have already taken one example. If you are not going for the upsampling, then in this case, you will not find, because in case of class imbalance problem, even high accuracy, that doesn't means like that this is a good model. If you are getting a high accuracy, that doesn't means like that this is a good model. So before, why this types of problem is coming due to our class imbalance problem. So that's why we are using the upsampling basically for balancing the data, basically for making the levels equal. Okay, now assume that we are taking three parameters: CGPA, 12th marks and 10th marks. Okay, CGPA, 12th marks and 10th marks. Okay, and now we are going to find which one is your important feature: CGPA, 12th marks or 10th marks, or all three are important features. Okay, now assume that we have calculated the 95% confidence interval and we are getting for place student the CGPA varies from 8 to 9.5, and for non-place student the CGPA varies from 7.5 to 9. Now in the 12th marks it will vary from 80 to 95%, and this one is vary from 70 to 80%. Now 10th marks it will vary from something like 70 to 90%, and this one will vary from 60 to 65%. Okay. Now can we say the first feature is an important feature to decide whether the student is going to place or not? Can we say If you are taking this is 95% confidence interval, means 95% case if the student is going to place, the CGPA of the student will vary from 8 to 9.5. In case of not place, 7.5 to 9. Can we say this is an important feature? Can we say? Anyone? Just you can put your answer yes or no. Can we say? Okay, so some are saying yes. Okay, now assume that if you are getting 8.5, can you decide whether the student is placed or not? Can you decide? If you are saying this is an important feature, if you are saying CGPA is an important feature, means definitely will get the different value of CGPA in case of placed student and different value of CGPA in case of non-placed student. Then in this case, we can say the CGPA is an important feature. Now assume that we are taking two students, A and B. A student A, now assume that in your class, the student have attended 70% lecture and a student B has attended 60% lecture. Now both are getting grade A. Can we say the attendance is an important factor to decide grade? Can we say? Can we say? Because if both are getting same, now you can see here both are getting the same grade, then in this case this is not an important factor. Or you can take some other example like that. There are two students A and B, and now assume that the two students whose 10th marks is 70%, and here also 10th marks is 70%, and one student is going to place and second student is not going to place. Then in this case, can we say this marks is an important factor? No, this mark is not an important factor because both are getting the same mark. Both are getting the same mark. Same like that here also. If there is any overlapping between this value, if there is any overlapping between this value, means definitely this is not an important feature. This is not important. Important feature means if you are getting the different value for placed student and if you are getting the different value for non-placed student, then you can say these are called the important feature. Now in this case, you can say this is an important feature because the 12 marks for the placed student varies from 80 to 95% and here 70 to 80%. Then you can say this is an important feature, but the CGPA is not an important feature because if you are getting 8.5, you cannot decide whether the student is going to place or not. So this is a first parameter. So before going for any feature selection technique, first you will apply some rank, some test or some test to find whether this feature, one feature is important or not. We are not going to check the combined basis. We are checking the individual basis, whether this feature is related to our objective or not. So this is a first step. And whatever the feature, if you are going to select it from here, that is called the significant feature. Okay, no, I am not saying like that each feature is important. I can say like that 10th and 12th marks is an important feature, but the CGPA is not an important feature. But the CGPA is not an important feature. This is your first step. Means whatever the feature you are going to select, that is called the significant feature, or that is also called the significant distributor. Based on this technique, you can easily differentiate between placed student and not placed student. So this is called the significant feature. Now next one is also important. Whatever the feature you are going to select, because in the machine learning technique, whatever the feature you are going to take as an input, that must be uncorrelated feature. There is no any correlation between this feature. Means whatever the feature you are going to consider as an input, that must be uncorrelated feature. Significant feature I have already mentioned. You can use the 95% confidence interval, or you can use some ransom test, or you can use some t-test to find the significant feature. You can use the ransom test, t-test, or 95% confidence interval to find the important feature. Okay, now next one, your uncorrelated feature. So as for example, now assume that if you are working for one project and your objective is like that, you will find how many students whose, just you have to find how many students whose age is greater than equal to 20 years. How many students whose age is greater than equal to 20 years. Can we consider date of birth and age both feature, or can we consider one feature, date of birth or age? Which one feature we will consider? Because in database now assume that we are going to put both feature, date of birth and age. In this case, can we consider both feature, or can we consider one feature only, date of birth or age? Anyone? So in case, we will consider only one feature. Either you will consider date of birth or you will consider age, because both are highly correlated. And how we know both are highly correlated? Because we have the idea about the domain. We have the idea about the domain like that. Age and date of birth both are same. There is no any difference between these two features. Okay. So, but in the case of if you have no any idea about the domain, then in this case you can use the Pearson correlation coefficient. You can use Pearson correlation coefficient to find whether the two features are highly correlated or not. And if two features are highly correlated, then no need to consider both features. You will consider exactly one feature. Okay. So after this step, whatever the feature you are getting, that is called the significant uncorrelated feature. That is called the significant uncorrelated feature. Now, after that, you can apply some feature selection technique to find the best combination of feature, or you can apply some feature ranking technique, or you can apply principal component analysis. But before applying this feature selection technique, first you go through the significant feature or uncorrelated feature. Okay. So these are the major steps I have written here. If you are going for the calculation of 95% confidence interval, you can use this formula. And you can also represent using the box plot diagram. If the boxes are overlapping, means this is not an important feature. If the boxes are not overlapping, means this is an important feature. So this is an important feature. This is not an important feature. This is not an important feature. This one is not important. This is an important feature. Something like that. In Python, you can use this diagram. In Python, you can write like that to get the box plot diagram or to find the significant feature. So you can use this ransom test to find the significant feature. So I am not going to this detail. Okay. Now I will not go to the machine line directly. I am going to the assemble technique. Okay. So directly I am going to the assemble technique. I have already given the idea about the assemble technique. So what do you mean by assemble technique? As we know, okay, so now one question is coming like that. In data set, all features are very, very close each other. Then how to decide which features to be considered? Well, that's why I have mentioned like that. You will use the Pearson correlation. Okay. Then you will find which features are, as for example, now we are getting A, B, C. These are the features and all three features are highly correlated. There is one correlation between A to B 0.9, A to C 0.8 and B to C 0.9, something like that. At a time, we will take A or B. Okay. So here 0.9, 0.9 means we are getting highly correlated. Now, in this case, just I am giving you the idea. In this case, we will find the accuracy of the model, or we will find the relationship of this output based on feature A and based on feature B. And which case we are getting the best result, we will consider those cases. We will not consider all the cases. We will consider those cases where we are getting the better accuracy. So if the two features are highly correlated, either randomly we will select the feature or we will go to the which features are highly correlated. Means if you go to the individual feature and then you will select which one is your best. Very, very close means how you are going to define. Very, very close means, okay, after this session, we will take this question. So in the question answer, we will take this question. Okay. So first I am going to complete this one, then we will take this question. Okay. So now in the assemble technique that we have already discussed, in the assemble technique, we already know not a single technique always give you the best result, because all technique will totally depend upon the type of the data. If the data is linearly dependent, then definitely your linear regression will give you the better result as compared to logistic regression. Same like that for the neural network. Also, you cannot claim like that the neural network will give always best result as compared to the other technique. Okay, so that's why we are going for the assemble technique. So there are two types of assemble technique and we will see one by one. The first one is called the homogeneous assemble method. So in the case of homogeneous assemble method, whatever the base classifier we will use, whatever the classifier we are going to use, all have the same type. All have the same type, but they have trained on the different data set. They have trained on the different data set. That is called the homogeneous. Heterogeneous means all have the different type of the classifier. That is called the heterogeneous data set. I will give you some example. Okay. Now, what we can do in the homogeneous data set, what we can do, we can use one concept called random sampling with replacement. We can use one concept called random sampling with replacement. Okay. So random sampling with replacement means now assume that if you have the 1000 data, okay, randomly we will select 1000 data, but with some replacement. Means if we are selecting this sample, one sample from this data, we are not going to remove from this sample. What I am saying like that, A, B, C, D, E. Okay. First time we are selecting randomly, we are selecting A, but we are not going to remove this data from the original data. Okay. Now the second time we are selecting B. Third time it may be possible like that you have selected the same sample. It may be possible because randomly we are selecting the data, but we are not removing the data from this original data. This is called the random sampling with replacement. Random sampling with replacement means basically we are not going to remove, we have already put it in this data. Okay. Now in case of homogeneous sampling, what we are going to do, randomly, this way, randomly we have to select 1000 data first time. Second time also we will select 1000 data. Third time also we will select 1000 data. Fourth time also we will select 1000 data. Fifth time also we will select 1000 data. Sixth time also we will select 1000 data. But in this case, all the data are different because we are using the random sampling with replacement concept. Okay, and we will use the same classifier C1, C2, C3, C4, C5, C6. As we know, the classifier totally depend upon the training data. Whatever the training data I will give, you will get the different classifier. If you are giving the different training data, you will get the different types of model. So in this case, we will get the 6 different model with 6 different. If you are using decision tree, you will get the 6 different decision tree model. You will get the 6 different decision tree model. After that, what we can do, we can use some voting. Now we can test. If you are going for the testing, now assume that this model is saying the output is 1. This one is saying output is 1. This one is saying output is 0, 0, 0, 1. Then we will consider the overall value is your 1. Then we will consider overall value equal to 1. Okay. Now this is a concept. I am not going for the some range you will consider. We are not going for the any range. This is a concept. Simple like that. Here basically we are not changing the technique. We are only changing the data. We are only changing the training data. We are only changing the training data. And how we are changing the training data? We are using the random sampling with replacement. We are using the random sampling with replacement. Okay, so we are using the random sampling with replacement, and then we are finding what is the accuracy of this model. We are using the voting mechanism. How many cases it is saying like that this is an important feature, and how many cases it is saying like that this is not a important feature. So in this case, 4 techniques are saying this is an important feature, then we can say what. Okay. Now again the question is coming, replacement means. Replacement means random sampling with replacement means, in this case, if you are selecting randomly one by one, we are selecting the sample. Okay. Now same like that, A, B, C, D, E, F. Okay. Now assume that you are going to select 6 samples from this data. Original data, the number of sample in original data is 6, and we are going to select 6 data. How we are going to select? First, randomly we have selected A, but we have not removed from original data. If you are going to remove from original data, then you can ensure that we will not get A again. But we are not removing from the original data. Now the second time we are getting B, and third time it may be possible we will get A. Then we are getting D, then we are getting F, and 1, 2, 3, 4, 5, and again we are getting B. This is your one sample of data. Again, we have to run the random sampling, we will get the different sample of data. Again, we have to run the random sampling, we will get the third sample of data. So basically, in the homogeneous assemble method, all techniques are same. Whatever the technique, either you will use decision tree or either you will logistic regression, neural network, all are neural network, but they have trained on the different set of data. Okay. Now, next one, your heterogeneous. in the case of heterogeneous, what we are going to take, we are taking the different model. This is a linear regression, logistic regression, decision tree, artificial neural network. We have to train on the same data. Here we are not using the random sampling or something like that. We have trained on the same data. After that, we will use some mechanism to find the value. We will see one by one. So basically, there are three different types of assemble model. If you are talking about the classification model, basically we are using the three different types of heterogeneous assemble model. One is called the base training assemble, second one is called the major voting assemble, and third one is called the nonlinear assemble decision tree forest. Now we will see one by one. Okay, first we are going to the base training assemble. That is also called the BTE, base training assemble. Okay. So in case of base training assemble, now we assume that we are using the cross validation method. Okay. So now what we can do, we are using the cross validation method. We have used the 5-fold cross validation method. So we have divided the data into 5-fold: data 1, data 2, data 3, data 4, data 5. Okay. Now we are using because we are talking about the heterogeneous, we are using the classification technique C1, C2, C3, C4, C5. All are different classification technique. Now we are going for the first iteration. So first iteration, we are taking this data as a training data. This one is your testing data. This is a standard cross validation method. We are using the n-1 fold data for training and 1 fold data for testing. So here we are using the 4-fold data for training and 1 fold data for testing. Okay. Now after based on this training, we will find the training error for all classification model. And we are getting like that. The classification C4 had the minimum training error. Okay, that will totally depend upon your objective. So whether you are going for the 5-fold, 10-fold, 20-fold. But most of the if you are talking about the standard method, we are using the 5-fold or 10-fold cross validation. This is a standard. But you can also go for the 20-fold, 30-fold. Even you can also go for the leave out cross validation, where you can use the n-fold cross validation, where n is the number of samples. So there is no any strict rule regarding the value of K. There is no any strict rule. So based on your objective, based on your domain, you will decide whether you are taking 5-fold, 10-fold or 20-fold, or you are using the leave out cross validation techniques. Okay. Now we will find the minimum training error. Now assume that the C4 is using the minimum training error. Now what we can do, we will not test this model on all data set. We will only test this model on C4 model. Means C4, whatever the model we are getting from the C4 training data or training technique, we can only use the C4 for first iteration. Now we are going for the second iteration. We are getting this one C3. Now we are getting the C3 is giving the best result. So here we will get the C3. Now in this case, we will test this data on C3. Now third fold, we are getting the something like C2. The next fold, we are getting C4, and next fold we are getting C1. So now assume that this one containing all classifiers C4, C3, C2, C4, C1. But we will not use all classifier for all the cases. We will use for some cases. Like for example, we will check whether this data is more similar to the first iteration data. If yes, then we will give the output as a C4 model. If this data is more similar to the second iteration data, then we will give the output as a C3 model. If this one is equal to third iteration data, we will only select the C2 model. Whatever the model we have trained, only on the C2 model. Means basically we are getting these types of models: C4, C3, C2, then C4, C1, and we are getting these are the data we have used for training. These are the data we have used for training. These are the data we have used for training. Okay. Now, if you are going for the testing, if you are getting one data, you have to check this data is more similar to which data. If this data is more similar to this one, then we have to train this model on C2. Then we have to train this model on C2. So in all the cases, we are not going to use all classifier. We are using only one classifier. This is called the base training ensemble. And if you are going for the algorithm, just you can see. So what we are going to do, select the data with n number of features. This is your data. We have the number of features equal to n. We are selecting the m number of classifier, and for k-fold cross validation means we are decide whether you are using the 5-fold, 10-fold, 20-fold, whatever the fold you are going to use. For each fold, k belongs to k. For each model, m belongs to m model. Train the model m on training data of k-fold. Apply the model m on training data of k-fold. Then compute the training performance of the model. And after that, you have to select the best model based on the training data. Then you have to test this model on the best model, not on the all the model. That's why it is called the best training ensemble. Now, next one is very easy. That is called the major voting ensemble. So in this case, basically we are taking the votes. So here basically we are taking like that. This is your ensemble techniques. Technique 1, C1, C2, C3, C4, C5. We will take the output. This is coming 1, 1, 1, 0, 0. So we will consider output as a 1. We will consider output as a 1 because we are taking the major voting. So we are going to assemble all the classifier and we are taking the major. How many cases this classifier is saying 1 and how many cases this classifier is saying 0. Now next one, here you can also modify. Just you can see here you can also modify. It will work. It will work for all the data. Whatever the data is there, it will work for all the data. Assemble technique, it will work for all types of data. Okay. Now, next one, we are going to modify this algorithm. Now, assume that we are talking about one student, S1. Okay. Now, there are different persons are there. One is called the placement division head, HOD of the department, one assistant professor, one 4th year student, one 3rd year student, one 2nd year student, one 1st year student. Okay. Now assume that these are the different model. Okay, and any student can communicate to the any model and they will ask whether I am getting job or not, or whether I will get job or not based on the current scenario. Okay. In case of major voting, what is the problem? We are giving the equal weightage to all classifier. We are giving the equal weightage to all classifier. But now assume that here 1st year student is saying like that. No, you will place 3rd year and 4th year students are saying place. But these 3 assistant professor, HOD and the placement division head are saying you will not place. What we can consider as an output, place or not place, anyone. If you are using the average voting, then definitely we will. If you are using the voting, then definitely we will go for the place. But in this case, can we consider place? Anyone can we consider place? No, because this person has more experience as compared to the student. But if you are going to the major voting ensemble, then in this case, you will give the equal weightage to all students. You will give the equal weightage to all model, but in some case, we cannot give the equal weightage to all models. So in this case, you can use some formula to define weights. So we will say like that, this is a placement division head, this is a more experience, so we are giving the 50% total weightage to the placement division head. Now we are giving this HOD, now he has also experienced 20%, 10%. This is a final year student, so 5, 50, 20, 70, 80, 85, 85. Then this is also 5, 90, and here we are saying the 5% and 5%, something like that. Okay, so based on some experience, based on some formula, we will give some weightage. We will give some weightage. Means we are giving the 50% weightage to the placement division head because he had more experience. He had more experience. Okay, he had more experience. Now the question is how to decide these weights. How to decide this based on the training error. Based on the training error. So now assume that if you are getting, now assume that the training error, if you are getting 0.1 here, 0.1 2 here, 0.3 here, 0.4, 0.4, 0.4, 0.4. This is a training error. Now we can find where we will give the more weightage. So these are the training error. After that, you have to find where we will give the more weightage. You have to find the average value. Then you will write 1 minus this value divided by average value. You will get some weights. You will get some weights. Okay. So based on that, we will find the weights. So how much weights we have to give to this one and how much weights we have to give to this one. Clear? So we can use some formula. So here basically we are using 1 minus this value divided by summation of all values. So you will get the weights. Something like that. So based on the training data, you will decide best. So less training error, give the more weightage. Less training error, we will give the more weightage. That's why we have written 1 minus something. Okay. Now next one is your nonlinear assembled decision tree model. Okay. So in this case, we are giving the weights. In this case, we are giving the weights. Okay. But now assume that we are taking one scenario. Now assume that this HOD has 20-year experience in Microsoft. Okay. And this question is, this student is asking the question related to Microsoft. In this case, where we will give the more weightage? Where we will give the more weightage? Overall placement, definitely the placement division head is good. But if now assume that if the HOD has 20-year experience in Microsoft, and if the question, if the student asking the question related to the Microsoft, then definitely this HOD is more experienced as compared to placement division head. This HOD is more experienced as compared to placement division head. So in this case, based on some domain, we are finding which one is more important. Same like that here also, what we can do, first we have to find. Now assume that we are getting 5 different classifiers. Classifier 1, 2, 3, 4, 5. Good. Now we are taking testing data 1. These all are saying 1, 1, 1, 0, 0. Testing data 2, 1, 1, 1, 0, 0. 1, 0, 0, 1, 1. 1, 0, 0, 1, 1. Something like that. Okay. So these are the testing data 1, 2, 3, 4. Okay. Now after that we will make this data, whatever the output we are getting from this model, again we will consider as an input of another model. Again we have to find the pattern. In which case we will use the classification technique 1. In which case we will use the classification technique 2. In which case we will use the classification technique 3. In which case we will use the combination of any classifier. Means what I am saying like that, we are using the 2-time training. Means first time we are using the data, and whatever the output we are getting from this one, we will put as an input of next technique, and again we will find the output. This is your final output. This one is your final output. Just you can see this one is your final output. So definitely in this case you will get the better performance as compared to the major voting, as compared to the average based assembling, as compared to the base training assemble. Because here we are doing the 2-time. Training. Whatever the output we are getting, again we will fit this output in this one. Then we will find the what is the original output. So now assume that the original output is 1, 1, something like that. This one is 0, 1, 1, and this one is coming 0, 0, something like that. Then in this case we can conclude like that. If the C1 and C2 both are saying 1, 1, that definitely the output will come 1, something like that. So when you are using some other training algorithm, definitely you will find the good model. So this is a 2-step model. First step, whatever the output you are getting, you will fit this output in the second model, and again you will get the output. So definitely this technique will give you the better result as compared to the previous 2 techniques. Now we will go for the assemble of the prediction model, because this is a classification model. So here you will get the output only 0 and 1. Because this is a classification model, means you will get only the output 0 and 1. Okay, but in case of prediction model, we will use the same way based training assemble. We will use the same way non-linear decision, whatever the algorithm you are going to use, but we cannot use the major voting assemble. Why we cannot use the major voting assemble? Because here the output is Here the output is 0 and 1, but in the case of regression technique, the output is continuous. You will get the continuous value. So in this case, we can use the average based assemble. Average based assemble means now assume that classifier 1 is saying 0.1, sorry, prediction 1 is saying 0.1, this is saying 0.2, 0.3, 0.2, something like that. Then we will find the average. Then we will find the average value. So in this case, we will find the average value, and that becomes the final output. So we will not take the individual, we will find the average. Again, you have the same problem. Here we are giving the importance to all predictions are same. Here we are giving the same importance to all prediction technique. But actually, we cannot give the same importance to all prediction techniques. So in this case, again, you have to calculate the weights, and how to calculate the weights. Here we have already defined some formula is just you can see. So this is called the average based, but here we will select the weights. So weights of the prediction model is selected using this one. So random of mi divided by I equal to 1 to m. So based on some training error, we have to define some weights. So basically this formula is something like called, here we are calculating the training error divided by total summation of training error. So based on that, we will get weights. And finally, we will calculate the output based on this weights value. Finally, we will calculate the output based on the weights. So as for example, here we will give the value weights like 50%, this one weights is your 30%, this one your 10%, 10%. We will calculate the value 0.5 into 0.1 plus 0.3 into 0.2 plus 0.10 into 0.3 plus 0.10 into 0.2 divided by total weights. So based on that, we will calculate the value. So up to here, any doubt? Up to here, any doubt in heterogeneous assemble method? If you have any doubt, then again I will continue. Any doubt up to here? This is not a mirror image. Actually, we are using the visualizer to write in here. So this is not a mirror image. This is not a mirror image. Okay, so any doubt up to here? Any doubt? So performance of the model means you can use the same thing. Accuracy, area under curve. If you are working for the class imbalance problem, then we already checked. The accuracy is not a good parameter. So we will go for the area under curve or F measure. If you are working for the prediction technique, you will go for the mean square error, mean magnitude relative error, mean absolute error, root mean square error. So these are the different performance techniques. So based on the same performance technique, you will find which techniques are giving the best result. Okay, now we are going for the homogeneous. That is also very important. Okay, so in the previous case, what we are going to use, we are using the different model. Okay, so now here basically what we are using the same model, but we are using the different training data. I have already explained about the random sampling with replacement. So here basically we are using the different sampling data. We are using the different sampling data with replacement, random sampling with replacement. So there are two different types of homogeneous assemble model. One is called the bagging and second one is called the boosting. So we will see one by one what is bagging and what is boosting. Okay. Okay. So now this one your bagging algorithm. So now I am going to explain you one by one. Okay. So bagging stands for the bootstrap aggregation. So first we will take the original data. This is your original data where n is the number of training example. N is the number of training data. Means this is your data where the number of examples is in, number of feature equal to n. Okay. Now after that we have to create the m copy of this training data using the random sampling with replacement. So you can use the concept called random sampling with replacement to create m number of training data. The same like that what our example I have given. So A, B, C, D, E. You will follow the random sampling with replacement to create 5 training data, 10 training data, 20 training data, something like that. So here you can claim like that all the training data are different. Okay. Then you have to train the same model H1, H2, H3 ... HF. This is same training technique. same training model on the different data, and finally we will calculate the model using this one. Means you will use the average. If you are working for the prediction technique, you will use the average, and if you are working for the classification technique, you will use some voting. Then definitely this model will give you the better result or useful for the model when we have the high variance and noisy data. And if you are using the Python, then in this case directly you can use this package to find the bagging classifier. Directly you can use this package to find the bagging classifier. Here you will define the base classifier, and here you will define the number of distributor. So after that directly it will give you the classifier value. So basically what I am saying, just you can see what I am saying in this case. Bagging is a simple. What we are going to take, same classification technique. If you are using the decision tree, same classification technique. If you are using the decision tree, okay. Decision tree. Now we assume that this is your data A, B, C, D, E, F. Okay. Now we will create the 4 set of data. First, but the same number of data A, B, C, F. Second one we have created because the random sampling with replacement. So we are not going to change this. We are not going to remove this data. Okay. Now second one we are getting A, B, D, E, F. Third one we are getting A, B, D, E, F. Fourth one we are getting A, B, C, something like that. Now we have to train this model on this data. First model, second model, third model, fourth model. Definitely all models are different because we are using the different training data. If you are working for prediction, after that you will take the average value. Okay. So finally we will get these types of model. This is your model 1, model 2, model 3, model 4. This is your output. If you are working for the prediction, you will take the average value. If you are working for classification, you will take the major voting value. But here we are using the same technique. This is called the bagging. So bagging is very simple. This is called the bagging. Now next one is boosting. So boosting is little bit different as compared to bagging. Okay, so most of the boosting algorithm, what we are going to do, train a weak model. We will select any model, weak model on some training data, compute the error of the model on each training example. Okay, give the higher importance to the example on which the models make mistake. So where we are making the mistake, we will give the more importance to that mistake. Now retrain the model using the importance weighted training example, and then again we will go to the step number 2. So this is step number 2. We will continue this process until we will find the best accuracy. We will see one example that is called the ADA boost algorithm. So that is totally based on the boosting technique. We will see one example. After that your concept becomes clear. Okay. So here basically the ADA boost classifier built a strong classifier by combining the multiple poorly performing classifiers so that you will get the high accuracy and a strong classifier. Okay. So basically what we are going to do, just you can see in case of missing, if the missing value in the data set, we will handle this missing value in data pre-processing algorithm. So there are various types of algorithm that we can use to handle missing value. But the step, if you are going for the machine learning, there are various steps are there. First one, data pre-processing, feature selection technique. Then you can use the classification technique. When you are using classification technique, you will define the validation method, cross validation or hold out method. Then you will go for the performance parameter. After that, again you have to go for the significance test. Okay. Now, boosting technique I am going to discuss. Now we are taking any classifier. Now assume that this is a weak classifier. That performance is not good. Okay, this is a weak classifier. Okay. Now assume that we are taking some sample A, B, C, D, E. These are the 5 samples are there. For A sample, we are getting the right result. B sample, right, wrong result, right result. Okay. Then in this case, in the next time when you are going to train, you will give the more weightage to this data. You will give the more weightage to this data using some error value or using some weight value that we are going to describe here. Just you can see. because this is very important, and this is also calculation based little bit. Okay, so now assume that first we are taking the training data that is the form of x1 y1. This is a set of features and y1 is your output, x2 y2 dot dot xn yn. This one y1 to yn, whatever the value is there, yi belongs to -1 or 1. So this is a classification problem we are taking, only -1 or 1 for all value of it. Okay. Now after that initially randomly you have to initialize the weight by 1 by number of sample. Means you will give the equal weightage to all sample. For all sample you will give the equal weightage, means all samples are important, so we will give the equal weightage to all sample 1 by 10. 1 by n. Okay, so if the number of sample is 5, if the number of data is your 5, then you will give 1 by 5. If the number of data or sample is 10, you will give the equal weightage 10. Means all are important now. Okay, now we will take the first round. We take any weak classifier, we are using the decision. Okay, now we will calculate what is the, based on the same training data, whatever the training data is present, based on the same training data we will calculate the, we will find the model, and then we will calculate the error of the model. Then we will calculate the error of the model. Error you already know, when the actual data is not equal to the predicted value, then we will calculate the error of the value. Error function equal to summation of n equal to 1 to number of sample weights, whatever the weights we have defined, into whatever the value. This is the output of the model, ht of xn not equal to yn. We will see one example, after that your concept becomes clear. Now assume that we have this data set. Okay, how many samples are there? Anyone? Can you count the total number of sample present in this data? Anyone? Can you count the total number of sample present in this data, and you will put your message here? Just you will put your answer in your chat box. So can you find the total number of data here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total number of data equal to 10. Where 5 are positive. So we are taking positive, 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 4, 5, negative, 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 negative. Okay. So basically we are taking 1, 1, 1, 1, 1, minus 1, minus 1, minus 1, minus 1. Okay. Initially we are taking the random weight. So 1 by 10, what is the weights? 1 by 10. 1 by 10, 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 same like that, 1 by 10, 1 by 10, 1 by 10, 1 by 10. Clear? Up to here any doubt? Up to here any doubt? If you have any doubt, then you will ask. Again I will explain. Up to here any doubt? We have taken one data where the 5 samples belongs to positive class and 5 sample belongs to negative class, and we are giving the equal weightage to all. Okay. Now assume that we have developed these types of classifier. This is your plus plus and this one your plus minus. Okay, plus plus minus. So in this, can you find how many are misclassified? How many samples are misclassified? Can you find? If you have developed this model, then can you find how many samples are misclassified? Anyone? 3. Good. So in this case, 3 samples are misclassified. We are going to take these 3 samples are misclassified. All are classified. Correctly classified means the predicted value is plus 1, but here we are getting minus 1, minus 1, minus 1. This one we are getting plus 1, plus 1, plus 1, plus 1. Sorry, minus 1, minus 1, minus 1, minus 1, minus 1. Because these are the correctly classified and these are the incorrectly classified. Okay. Now we will put in this formula and we will find out what is the error of this data. Okay. So what is the value? First value. First one you correctly classified. So what is the value we'll get? This value is false. What we have written? ht of xn means basically what is the predicted value of xn, that you 1, not equal to 1. Condition is true or false? False. If the condition is false, it will return 0, and 0 into something, what value will get? You will get 0. 0 into something, what value will get? 0. Okay. So in this case, we will get 0 for this one. We will get 0 for this one. Now we will come to this point. Just you can see what is the DTN 1 by 10 into here what value we are getting? Predicted value minus 1, actual value plus 1. Means this is a not true. So means -1 not equal to +1. Condition is true, so it will return 1. So we will write 1 into 10 into 1 plus. This one also will get 1 by 10 plus 1 by 10, and for the rest of the value we will get 0, 0 something. So can we say this error value is nothing but equal to 0.3? So this error value for this model is nothing but equal to 0.3. We are using this formula to calculate this error value. So just you can see we are using this formula to calculate this error value, and these values are coming 0.3. Now we will calculate the importance, how much classifier, how much important this classifier is, because it will totally depend upon the error. If the error is low, this classifier is more important. If the error is 0%, this classifier is the best classifier. If the error is 100%, this is your worst classifier. So we are giving the importance to the classifier alpha t equal to 1 by 2 log 1 minus 0.3 divided by 0.3. Okay, so what value will get? 1 by 2 log 0.3 divided by 0.7 divided by 0.3. So now we are going to calculate this value. Just you can see. So what value will get? 0.5 into log 7 by 3. 7 by 3. So we are getting the value equal to 0.4236. 0.4236. So the importance of this classifier is 0.4236. This is the first step. Now, because these are the misclassified, now in the next step, we will give the more important to this classifier. We will give the more important to this sample. So now you can see we are using the update formula. Just you can see we are going to update this model. The next weight dt of 1 of n equal to dta of n into exponential value minus alpha t into yn into ht of xn. Okay, ht of xn. Now here one important point. Just you can see what is the value of yn into ht of xn. Ht of xn means predicted value. Yn means actual value. So what is the yn into ht of n in case of correctly classified and in case of incorrectly classified? Anyone? In case of correctly classified, what is the value will get? What is the product of this value? What is the value will get? When you are going to correctly classify, what is the value will get? Correctly classify means output is 1 and predicted value is also 1. Output is -1, predicted value is -1. Can we say this value is always 1? Can we say always 1? In case of incorrectly classification, output is +1, this one is -1, or this one is -1, this one is. So can we say this value is nothing but -1? Now we will put this value and we will see. Just you can see dt plus 1 of n equal to dt of n into exponential value minus alpha t in case of correctly classified, and dt of n into exponential of alpha t in case of incorrectly classified. This is the output we will get. In case of correctly classified, we will get this value minus alpha t. Means definitely we are reducing the weightage. We are giving the less weightage to the correctly classified, and we are giving the high weightage to the incorrectly classified. Okay, alpha t we have already calculated. All case this value is 1 by 2 into exponential of alpha t we have already calculated 0.4236. So now again we have to calculate ext of 0.4236, 1.52. So 1.52 divided by 10, 1.5275 divided by 10, it will come 0.1527. Now this one we will also calculate minus. So this value will come 0.065. So now you can see. So in this case, just you will see what is the important. This is your correctly classified. In the correctly classified, now initially your weight is your 0.10. Now your weight becomes 0.065. So now we are going to write the weights here. Just you can see initially this value. So now we are going to write the weights here. This is correctly classified. So weight is 0.06, 0.06. This one is 0.15, 0.15, 0.15, and this is correctly classified 0.06, 0.06, 0.06, something like that. Okay, now the first step is over. Now we will go to the next step. Again, we will use the same classifier. Again, we have to train the model. Again, we have to use the random sampling with replacement. Again, we have to train the model, and we will find in which case we are getting the incorrectly. Now assume that we are getting these types of H2. Now we are getting these types of H2. Can you calculate the error rate? Can you calculate the error rate using the same formula? Now, in this case, can you find how many cases we are getting the misclassification? What is the misclassification error in this case? Again 3, but this time we are getting for the negative number. This time we are getting for the negative number, and we will calculate this value. This value will come 0.65. Again, we will go for the third case, and we will calculate this value. We are getting the 0.92. This is the importance of this classifier. Finally, we have to merge this classifier like that. This is your 0.42 into first classifier plus 0.65 into the second classifier plus 0.92 into the third classifier, and based on that we will find the output. Based on that we will find, we are giving the importance, we are giving the weightage. With 92% weightage we will give the classifier, 0.65 weightage we will give the second classifier, 0.42 weightage we will give the first classifier. So now assume that if the third classifier is predicting 1 and the first two classifier is predicting -1, that in this case your output become minus 0.42 minus 0.65 plus 0.92. So you are getting negative numbers, you will consider -1 output. You will consider -1. Now assume that this one is saying plus, so you will consider positive number. So this is called the ADA boost. So now you can see this is your overall algorithm. I have written the same thing. This is your overall algorithm for that. Just you can see this is your overall algorithm for the ADA boost classifier. So up to here, any doubt? Up to here, any doubt? Okay, so now clear. So I think I have only 5 minutes time. So now I'm going to describe you how to put this result. Okay. Now most of the time I observed that in your research paper you are only putting these types of table. You are only putting these types of table and you are writing the accuracy of the model. But can you find which model will give you the best accuracy? Can you find anyone? Can we find which model will give the best accuracy? Because in your paper, most of the time I observe like that, when you are writing the paper, you are simply putting these types of table and you are finding this model is giving the best result. But after that, the reviewer also needs some time to validate your conclusion. Okay, so in this case, can you find how much time it will take to find your conclusion is right or not? Okay. So in this case, just you can see, so you can compare all the values. You have to compare all the values, then you will make the conclusion. But when you are putting the same thing by using the box plot diagram, then in this case, within a second, you will find which one is your best technique. The model which have the high value of this red line, that will consider as a best technique. So can you find which one your best technique? Can you find in this case? Can you find which one your best technique? Which model have the high value of this red line? Definitely the ELM with polynomial kernel. So how much time it will take to find? Now assume that you are doing this analysis and you are going through the box plot. Which one will take less time? Box plot or first one? Definitely the box plot will take less time to find your conclusion. Same for this 3 different original data, downsampling, upsampling, random sampling. Directly will find the upsampling will give the better result. But when you are going through this technique, again it will take time. You have to compare all the values. Here you will compare, here you will compare, then you will find the conclusion. After that, most of the time I observe like that, we are going to stop the paper. Most of the time we are going to conclude after making this chart, after making this diagram or this table. But after that, there is one important point that is called the ransom test. You have to prove that whatever the model you are going to develop, all are significantly different. If you are going to propose your own algorithm, then in this case you have to prove that your algorithms are significantly different from whatever the algorithm available in the articles or whatever the algorithm available in the market, something like that. So in this case, just you can see here we are using the ransom test to check that whether the model developed by using these techniques are same or different. So here you can see we are using the two different symbols. Cross means there is no any significance different. Circle means there is a significance different. Based on the performance, just you can see which one is giving the best result. ELM with polynomial kernel. Now here you can see the ELM with polynomial kernel and linear kernel both are same. There is no any difference between these two models. We are getting the cross. Now you will tell me which one we will use, because both models are same. There is no any difference. Significantly both models are same, but little bit ELM with the polynomial kernels are giving better result as compared to linear, but both are same. So in this case, definitely we will go for the linear regression, because the linear regression is a simple model, y equal to mx plus c. That is simple model. Same like that, here you can see if you are going for this technique, then in this case Wilcoxon-Sinang test is giving the better result as compared to cross correlation. Now here you can see both are same. There is no any difference between these two techniques. Both are same. Okay, so in this case we will go for those techniques which have the least number of input node, and definitely cross correlation has less number of input node. So these are the major steps. So first one, if you whatever the data you are getting, first you will go for the univariate. Means first we will go for the data pre-processing. You have to remove the outlier. You have to handle the class imbalance problem. Then you will also focus on the duplicate data. You will also remove the noise. You will also handle the missing data, something like that. Then you will go for the feature selection. The feature, before applying any feature selection technique, first you have to apply the univariate analysis. Then you will go for the feature selection. Then you will go for the classification technique, and when you are going for the classification technique, you will define the validation method. And nowadays, most of the time we are using the cross validation technique. After that, when you are getting the model, then you will find the which model is giving the better result. But in your research paper, always try to put your result in the form of graph, because as we know, the human mind can easily observe the graphical thing as compared to the textual part. Okay, so we always represent our result in terms of graph. Okay, so same like that, just you can see. So here also we have represented our result in terms of graph. Just you can see these are the results in terms of graph. So you can easily find which techniques are more important, which features are more important. But when you are going to write the same thing in the table format, minimum of CBO is important, minimum of CA is important. Again, you will get the huge table, and again it will take too much time to validate your conclusions. Whatever the conclusion you have written, again it will take 5 to 10 minutes time to find whether you have written the right conclusion or wrong conclusion. So always try to represent your result in terms of graph. And the most important is like that you have to prove that whatever the model you have developed, whether the models are significantly different or not. And if the models are not significantly different, then in this case definitely we will go for those models which have the less complexity, which will take the less time to train, which will take the less time to predict. Okay, so if you have any question, then you will ask, because we have only 2 minutes left. Okay, so some classifier giving the okay, and okay, just one second. I'm going through the whatever we have question, just you will put in your chat box. Okay, so in this case, first based on the accuracy wise, we will go for the classifier having 80% accuracy. But after that, you have to prove that whatever the first classifier, both are significantly different. If both are significantly different, then we will go for first classifier. If both are significantly same and the complexity of second algorithm is less as compared to the first one, then definitely we will go for the second algorithm. We will not go for the first algorithm. In case of class imbalance problem, accuracy is not a best parameter. In case of class imbalance problem, we cannot use the accuracy. So I have already given example. Now assume that your data is highly imbalanced. You have the 1000 sample, out of 1000 sample, 990 sample belongs to one category and 10 sample belongs to other category. You will get 99% accuracy. Even the model is only predicting the student is going to place. So even the high accuracy doesn't mean that the good model. Means definitely this is not an important parameter to decide whether this is a good model or worst model. So in this case, in case of class imbalance problem, always we will use area under curve. And whatever the conclusion we will always make on the area under curve. Okay. Now next question, high accuracy or low computation. First one, high accuracy. If you are taking high accuracy, then you have to prove that whatever the model you have developed that are significantly different from other model. If you are getting the high accuracy and second one little bit low accuracy and both are same, there is no any difference. Significantly, there is no any difference between these two models, then definitely we will go for the low complexity. Definitely we will go for the low complexity. So any doubt?
Dr. Love, you please share your email ID. Okay, we are running out of time.
Sure, sir.
Please
Sure,
share your email ID and mobile number if possible, so that
sure,
they will contact you.
sir. Sure, sir. So if you have any doubt, then you will mail me lovekumar505@gmail.com, or you can even call me at 260-612874, or even you can WhatsApp me. Okay, so if you have any doubt, then you can call me. And if you need any code related to the today session, then even you can also message me or you can also email me. So I will share you the Python code as well as MATLAB code. Thank you, sir. Thank you, Saurabh, sir.
Okay. Thank you very much, Dr. Love. Okay, I request all the participants, those who are working in this field, as Dr. Love Kumar is a very good researcher in this field. You can take help of your work. If you are doing some PhD work or some student, some of your students are working for in some institute. Okay, if they need any help, or you can also invite Dr. Love Kumar for giving talk in your institute, because he has very rich knowledge in this field. So thank you very much, Dr. Love Kumar. You are a very interesting session. I enjoyed your lecture.